So I'm talking about lessons from Infosec incidents tonight, and this little picture here is kind of a metaphor for what we're talking about really. So you've got your secure house there with the big gates and the wall and the hedges and the spikes on the top, and you've even got a couple of lions to protect the place. But you know, you make a basic mistake and it's all for nothing. So really we want to make sure that breaking into our systems isn't child's play. So my name is Minto. I work for a company called Buybox, who you probably haven't heard of. We're a supply chain management technology company. We make web apps, mobile apps, bespoke back-end systems for various customers who need supply chain fixing things really. So our customers have complicated supply chains, we make them better. It's probably a better way of saying it. So why am I talking about security? Well, I've been interested in security for a long time. These are BBC Model B micro computers. I don't know if anyone's familiar with these, but we had a lab very similar to this in school, rows of these things. And I used to have a lot of fun with a mate of mine. Back in the day, pair programming meant one of you reading code from a magazine while the other one typed it in. And that's what we did, this mate of mine and I. And we took various bits of code and we brought them together. And we wrote a little app which basically took over the entire network. So we had all of the BBC micros showing a little graphic and playing a little tune while the teacher at the front of the class kind of stood there a bit bewildered, not really understanding what was going on. So I've been interested in sort of security and hacking and that sort of thing ever since. That friend of mine went into pen testing, worked at Oracle, Google, and he's now CISO, Chief Information Security Officer at Snapchat. I went into application development, so rather than directly into security, but you know, that's why I'm here talking about it. So why do we care about security? Well, to avoid headlines like this for a start. This is VTech in 2015 now, and you know, they make toys for kids. I've got kids, I don't know about you, but you know, I don't want my kids' photos and messages and all that sort of stuff broadcast across the internet, which is effectively what VTech did. So you know, they had a vulnerability and they didn't really handle it very well at all. So we want to avoid stuff like this. 4.8 million records they lost. Is anyone familiar with this website? A few nods in the room. So yeah, have I been pwned from Troy Hunt? Now, almost 5 billion when I took this snapshot of pwned accounts, and I think that's a lot more now. You know, we don't want to end up on this list for sure. And this has been mentioned already tonight, the GDPR. Anyone familiar with this? Yeah, a few nods. So data protection is getting a bit more focused now. So you know, we've had data protection in the UK for years, but you know, with fines up to £500,000. Well, so the maximum the ICO could fine in the UK was £500,000. And the maximum they did fine was companies like TalkTalk and Carphone Warehouse, which was at 400,000. But under GDPR, the maximum fines are 20 million euros or 4% of global annual turnover. So much more significant. So I think that's getting attention of, you know, companies, that especially, you know, the board. They're all thinking about it in that way, and it's a great way of actually saying, look, we need to do security a bit better anyway. So you know, this is a good reason, another good reason to do it, as far as I'm concerned, because we are doing a really bad job of it. This is another stats website. This is breachlevelindex.com. So again, nearly 5 billion records lost since 2013. But actually that is July 2016, and we're now nearly 10 billion records. And if you look at the number of records a second. We've got 41 records a second lost at that point, July 2016, and we're now doing worse. It's now 59 records a second. So, you know, we're not getting any better. So how do we fix it? What are the lessons? So the first lesson for me is know your enemy. Now, we're probably all familiar with this picture, the archetypal hacker. You've got a guy in a hoodie, shadowy figure, green text, matrix styly. You know, we've all seen this before, but I think it's a bit more nuanced than that. It's, you know, you might have this sort of hacker. It could be a script kiddie, someone just doing it for fun. So it could be a disgruntled employee, or, you know, that sort of insider helping others. Could be a hacktivist, your anonymous type. Could be organised crime, industrial espionage, terrorism, that sort of thing, all the way up to nation state. So you need to understand where on that spectrum your threats lie. Some interesting stats. So 25% chance it's an insider, 75% outsider. These are stats from the Verizon Data Breach Investigations report. In terms of knowing your enemy, for me, how many people use user stories? Yeah, a few hands. I like to think about evil user stories, so put yourself in the position of your attacker from that perspective and write some evil user stories, include those in your scope. And understand their motivations as well. So money's a big motivator. 73% of breaches, the motivation's money. Now, this is an interesting incident we can learn a bit from. This is William Hill, who suffered a DDoS. So bookmakers and gaming websites are particularly susceptible to DDoS. And you know, if they're making a lot of money and someone can take them off the internet, then they're susceptible to blackmail. There's one. Another good reason for DDoS, I heard, is distraction. So somebody DDoSes your website over here, you're all focused on that, and they're doing something else to your company over here. So there's all sorts of reasons. And it could be big companies like William Hill, or it could be any of us really, from my perspective, because of people like this. So this is a young lad from Worcestershire who was charged with running DDoS services. So he would he'd spin up a service which would allow you to just come along and pay for a DDoS on someone else's website, take them off the net, and you know, these kids are DDoSing each other because they just for the laugh, really, or you know, they're playing on gaming networks and they just want to knock each other off Doom or whatever the kids are playing nowadays. Is it Minecraft? I don't know. Yeah. So I talked a bit about DDoS without really explaining what it is. So let's do that now, for those of you who don't know. So you've got an attacker on the internet, you've got your web server, the attacker's got a command and control box. He sends, and some zombies as well on the internet. So these could be PCs that have been compromised, or they could be badly configured machines. So he sends a request to his server, that then sends a request out to all of the zombies. They then send as much traffic as they can at your website, flooding your pipe, taking you off the net. So, I mean, those might be servers, could be anything web, email. Memcache has been a problem recently, so public Memcache servers on the internet allowing massive DDoS, as Mark mentioned earlier. I mean, they can even be routers, webcams, you know, anything can be used in this way. So it's a bit of a problem. Now you can solve it quite easily by throwing something like Akamai or Cloudflare in front of your web server, but you know, they're going to charge you for it. Oh, and I just throw in OVH as well for Mark's benefit. You know, they offer these kind of services as well. if you're on their system. So what else is there to talk about? Well, covering the basics, I think, is a good lesson. What's the issue with this website? So I'm logged in over here. What's the issue? Yeah, so it's a bit small, but yeah, no HTTPS. So for me, HTTPS is security pixie dust. It's kind of a great way of dealing with a lot of these issues, and it's kind of becoming de facto standard now. So people expect it more and more, and the browsers are kind of forcing you down this route by pointing out to your end users that HTTP is not secure. So this mitigates all sorts of issues with sniffing, insecure Wi-Fi networks, that sort of thing. Some of the features in things like HTML5 only work with HTTPS, so lots of reasons to go down that way. And it's inexpensive or free, so Let's Encrypt have done a great job in pushing HTTPS because they'll just give you a certificate. But you do need to make sure that you've set it up properly, so you can use tools like this. This is SSL Labs from Qualys. So you point this at your server and it'll tell you whether your configuration's correct, what ciphers you're using, how you've set up, that sort of thing. But yeah, you really do need to validate your SSL configuration. Another little useful online tool along the lines of SSL Labs is this one from a guy called Scott Helm. This is securityheaders.io. So you basically point this at your site and it tells you what headers, HTTP headers you can add to your website to improve your security. Now this is not really wanting to pick on Tesco, but they are in the Hall of Shame. They're also in the Hall of Fame as well. I'll show you why in a second. So if I just pop over to browser, this will be fun. So if I just put in tesco.com, so you give it a URL, it goes off and scans your website, tells you whether you're doing a good job or not. But one of the good things is it will then tell you what headers are missing and how you can add them. So I can probably zoom in. So you say, this is what's missing here. Yeah, the content security policy I'll come back to, but there's a few other basics there that can be really helpful. These are all basic things that you can just add in fairly easily, and Tesco haven't done that. Except if I do that, change the URL slightly to a different Tesco URL, they get a much better result. So in this case, all they're missing is referrer policy, which is a newer header anyway, so we'll forgive them for that. But it just shows that you need to look at the whole of your application. You can't just look at part of it. And that's securityheaders.io.
You're really into computers, huh?
Yeah.
What are you doing?
Dialing into the school's computer. They change the password every couple of weeks, but I know where they write it down.
So to me, that shows how things have moved on. I mean, I used to love this film, Wargames, from 1983. That's I don't know if anyone's familiar with two-factor authentication, but I think of that as half a factor, so just the password, and you write it down. Yeah, so things have moved on, but not that much. This is a This is an incident that affected the government, so parliamentary email accounts were compromised, and this was a brute force attack. So what that means is somebody found a set of email addresses and passwords that have been used and compromised on one site, and they start feeding them into the government's email authentication system, and they get some hits because people reuse passwords. And there's a fairly simple solution to this, and that's two-factor authentication. So add in something as well as your password, like a unique code on a mobile device, and it's pretty simple to do now. You can, in .NET, you can do it in ASP.NET Identity. You can add two-factor pretty simply. You can use something like Identity Server. There's lots of solutions. So we should really be getting better at passwords, because passwords are kind of the cause of 81% of hacking related breaches. So in 81% of breaches used stolen or weak passwords. And the guidance on passwords has moved on. So no longer do we have to have massively difficult to remember passwords that we have to change every couple of weeks. So the advice is be nice to users. We get rid of complexity rules, and we instead of that we have different mechanisms for protecting our users and their data and our applications. So you have much more complex authentication mechanisms. So your app does the hard work rather than forcing that on the user. But there are certain rules that we still get users to follow. So make the passwords long. You can have any sort of character in there, even emojis, and encourage the use of password managers. So you'll see some sites actively preventing password managers and things like paste, but we want to encourage people to use the likes of LastPass and 1Password, because then you can have these really complex, long, impossible to guess passwords, and you can use different passwords all over the place. No periodic changes, I kind of mentioned earlier, and that's kind of the latest advice. So really, you don't need to be changing your password every month, every 3 months, because all users were doing was just modifying their password slightly and reusing it effectively, and then they'd still use the same thing across different sites, and that's behaviour that we need to train away. So that's, again, password managers are great for this. If you can encourage your users to do that, brilliant. Easier said than done, of course. Banning common passwords. I think this is a really interesting thing. I mean, Buybox have been doing this since about 2012, and we've got a list of hundreds or thousands of common passwords in the app, and it won't let you choose one of those because we know how bad they are. And we also include things like Buybox and variations on that because we know that our users might choose that. And there's also a new API from Troy Hunt who created Have I Been Pwned. He released all of the passwords that he created or he gathered together as part of that service in his Pwned Passwords service, I guess you call it. So he did that a year or two ago, and then recently came out with a V2 where he got more passwords, I think 500 million. And he changed the way the API works. So that's really interesting now, because you can ask his API in a secure fashion whether or not this password has been pwned, and then prevent your users from using it, or warn your users that they're going to use a password which might be compromised in that way. And that's really interesting. And two-factor authentication, again, is a great way of strengthening your authentication. Yes, if your password's compromised, they still need that second factor. But watch out for newer attacks which will try and persuade your users to enter their second factor into the compromised website. That's going to be a thing soon, I'm sure. But all of this guidance is new. It's coming out of places like the National Institute for Standards and Technology in the US, and the National Cyber Security Centre in the UK, and even Microsoft, and they're all coming around to the same sort of advice like this. Along the same lines, Uber had a bit of an issue where they stored security credentials in GitHub. So don't do that. Don't store secrets in your source code repository, or if you absolutely have to, encrypt them. But it's not a great idea. You know, even if you perhaps got a private GitHub, you might assume that one day it's going to be public, whether that's by accident or somebody's intention. So you know, you can't rely on that stuff remaining secret. And there are bots scanning check-ins on GitHub looking for, you know, AWS credentials in commits, because as soon as they see them, they're going to start spinning up virtual machines on your AWS infrastructure if the keys enable them to, and they'll be mining cryptocurrency, and they'll basically be turning expensive electricity into rubbish bitcoins or similar. Really inefficient way of making money, but they don't care because they're not paying for it. Amazon have certainly got some script that will scan your commits as part of your you know, as a commit hook. You can check for AWS credentials, and there's a neat little app script on GitHub called Truffle Hog, which scans Git repos for high entropy data. So anything that looks like a key, it will flag that to you. So there's some interesting things there. So you can find your credentials that have been accidentally placed into source code before somebody else does. Is anyone familiar with AWASP? Couple? Okay. So I mean, this is a really useful resource. AWASP is a charity, a set of user groups all over the world. They produce projects, articles, documentation, and security standards as well. You know, really good resource for getting some of the basics covered. One of their flagship projects is called the AWASP Top 10. Now the AWASP Top 10 looks at the top 10 most prevalent, risky, common vulnerabilities in web applications. They've got a mobile top 10 as well, a few spin-off projects like that. But you know, they take some data from the security community, from pen tests and vulnerability assessments, that sort of thing, collate it all together and work out which are the most common vulnerabilities, which are the riskiest, which are the easiest to exploit, and they rate them 1 to 10. So this is a great place to start if you want to look at a particular application and where the vulnerabilities are. And the number one is, and has been for a while, injection. So I don't know if everyone's familiar with this. This is a cartoon from XKCD talking about little Bobby tables. And it's the story of how a parent has named their son in such a way that it causes a SQL injection problem in the school's computer. So yeah, that's an interesting lesson. I'm not sure the mitigation that he suggests is particularly good, but you know, so injection is untrusted input coming from anywhere really. It could be somebody's name. You'll see examples where people have put a SQL injection into, say, a car registration or something on the back of a car that might get recognised by a automatic number plate recognition system. You know, you see all sorts of interesting things. People put them in DNS records, and yeah, you'll see them all over the place. Oh, Company's House. There's a company registered in Company's House. Did you mention this to me last week? No, it wasn't you. Yeah, there's certainly a company registered with, you know, -- drop table companies, and you can go on Company's House and see that. So you know, it's really common, often quite easy to exploit, and fairly straightforward to deal with actually in our code. So certainly in .NET, I mean the framework's kind of guiding you down the right path, but you can do the wrong thing. You know, you've got to be careful when you're parsing your when you're building those SQL strings. In fact, don't do it that way. We'll talk about that a bit more in a second. But in terms of the exploits, this was an interesting one. So I mentioned TalkTalk earlier, and here's that £400,000 fine, and that was a SQL injection attack. And the ICO, the Information Commissioner's Office, the data protection regulator in the UK, said, you know, TalkTalk should have known about this and fixed it. And it's not just you know, little companies like TalkTalk. You've got big companies like Facebook, and you know they own Instagram, and Instagram had a bit of a problem with comments being deleted from their website. This is a FBI flash talking about election systems with another SQL injection vulnerability. So, you know, this is quite a common problem, which is why it's number one. And it goes back a long way. So this is Frack, which is an online hacking magazine. I think probably paper-based at one point, but this is 1998, I think, December. And in that, you know, here's SQL injection and how it's a problem in Microsoft SQL Server. So, you know, it's been around for such a long time and we're still not quite there in terms of fixing it. This is just a really basic example of how it works. You know, you've got a username and password form on your website, and you're taking the username and password from that form and building up a SQL string. And if you put the right bit of code in there, you end up completely nullifying the password, and you can log in with anything. And it's kind of as simple as that, really. And it's just a question of processing that untrusted user input properly. You know, it could be a form, it could be a query string, it could be a cookie, HTTP header. That data can come in from a variety of different places, and it doesn't have to be SQL. It can be LDAP, you know, NoSQL as well. They're all affected. And the mitigations are pretty common. So parameterizing your SQL queries or your NoSQL queries, using least privilege principles. So, you know, if your web app's talking to a database and it shouldn't be able to write to it, then just make it read only. Don't let it access the file system, those sort of mitigations. Or you can whitelist your inputs as well. So if you can restrict the username that your app's accepting, for example, maybe you could say that only alphanumerics acceptable. That's a good way of dealing with that. But you know, parameterization is kind of the primary mechanism for this. Any Ashley Madison users in the room? It's funny, that always gets a chuckle. It's funny how many people know what Ashley Madison is. I don't necessarily always have to explain what it is. But yeah, so they had a bit of an issue, old Ashley Madison. Great website if you want to have an affair. I've never used it myself. They had a lot of problems with their systems, but the flaw I was going to talk about was one which basically compromised their users' passwords. So their users were pretty compromised already, and not only that, but they lost their passwords too, because Ashley Madison had made a bit of a mistake in their authentication. So they were using a great encryption algorithm for their passwords in one part of the system. They were using an encryption algorithm called bcrypt, which is good, works very well, very strong, hard to brute force. Yeah, thumbs up all round. However, they also hashed the passwords with an algorithm called MD5, which is terrible for passwords, and that was elsewhere in the system. So it meant that as soon as people noticed that had happened, the passwords were effectively in the clear, in plain text, and that's what happened to them. And to me, this suggests this talks about authentication. You know, we can do a much better job of authentication. I've mentioned ASP.NET Identity and Identity Server as two options in .NET. So rather than rolling your own, you can use those. You can also use a third-party service like Auth0. There are a few different other ones around. Or you could use social logins like Google or Facebook, that sort of thing, if that's your cup of tea. You know, but you're not having to write all of that stuff yourself. You're letting somebody else manage that for you. You're not having to worry about passwords that you can then lose. If you do have to roll your own, make sure that you're storing your passwords securely, so you know, not in plain text, and you're not using reversible encryption. You're using a hashing function, and those include things like bcrypt, scrypt, PBKDF2 is another one in the .NET framework, and you're not using stuff like MD5. You're not using the SHA family of hashes because they're just too fast for storing passwords. Fast sounds like a good thing, but when your attacker is going to brute force your passwords by throwing different passwords in there to see if they can be cracked, then fast is bad. Salting, another mechanism in there, which is great. So I won't go into the detail, but you should salt your passwords. And crypto agility is something that I don't hear enough about. Now bcrypt, the bcrypt algorithm for hashing includes crypto agility and salting kind of out the box. You don't really have to do anything, it just does it for you. So the salting is just a random bit of just a random set of bytes that you include with your password, makes the brute forcing more difficult. But the crypto agility part of the algorithm is really interesting for me. So bcrypt includes a work factor. So you say, you might say, this year my work factor is going to be 10, but next year, as the speed of processors and GPUs improves and brute force attacks against bcrypt get faster, then you might want to increase the work factor. And the work factor means that the bcrypt algorithm works harder to protect that data. And you can extend that concept for crypto in crypto agility terms by not only having a work factor with your passwords, but say having the algorithm choice as well. So you might switch from bcrypt to scrypt in the future, and just having that ability to do that with config in your code rather than having to rewrite and change your you know, if you architect for it in the first instance, it's going to be a lot easier to migrate forwards. So that for me, that's a really interesting thing. So, and it doesn't just apply to passwords, it's any kind of crypto. So if you're encrypting now, you're encrypting with AES 256, you know, next year you might want to encrypt with AES 512. So you're kind of thinking about that and the way that you're encrypting now. Yeah, so they lost a load of passwords. This is an eBay issue back in 2016, and it's cross-site scripting. Oops. Now, cross-site scripting's dropping down the AWASP top 10. So it was at 3 and it's now at 7. And I think one of the reasons for that is that the browsers are getting a lot better at protecting against this, and frameworks too. But I think it's going to get a bit of attention. I'll talk a bit about why in a second. But just a quick example of a cross-site scripting attack. Again, there's got a username parameter. Say this could be a query string, or it could be a form parameter. And instead of a username, I've actually got a bit of script in there, a bit of JavaScript. Now, if that is rendered into the page and that script executes, that could send all my cookies off to some attacker's website, and that's kind of not what you want. And that's just the tip of the iceberg. You know, once you're running JavaScript in somebody's browser like that, you've got an awful lot of control over that browser. And it's the same problem with SQL injection. It's this untrusted user input that's just coming at our website. You know, lots of vectors, as I mentioned, you know, HTTP headers, forms, etc., etc. Now, there are various mitigations for this. Some of them are built into the framework already. So, .NET's certainly leading you down the road of encoding your HTML properly, but you do have to make sure that you're encoding for the right output, whether it's HTML, JavaScript, CSS, etc. There's request validation in .NET, which helps with this. Don't turn it off. And content security policy is, I mentioned earlier, that's a really good defense against this and a variety of other attacks. So content security policy is an HTTP header. So you send that down with your web app, and you can specify how you want your app to behave, where it's getting its script from. So certainly in the case of cross-site scripting, it's often the case that the attacker will effectively run inline script in your page, and with the right content security policy, you can say, don't allow inline script to run in my page, and therefore you've killed that that vulnerability already. So I think that's a really powerful mechanism. And I just wanted to show you a quick demo which demonstrates the power of cross-site scripting. So this is Bob's Discount Diamonds. This is a website which I created to be deliberately vulnerable, so you know you can browse it. You can just pick a diamond, you know, etc. You can also send a little message to the website owner. Send that, you know, and it pops it up here. Now, because it's sending it back to the browser, this is where I've got my issue with cross-site scripting. And if I send it the right bit of text, now what's happened here is I've sent it some JavaScript which is running the browser, and now I've got control over the browser through a thing called Beef, which is the browser exploitation framework. And from this point, I can send any other JavaScript payload down to that browser. So what I'm going to do is send this command down. So the browser is now actually polling my server for JavaScript. And hopefully, there we go. So you can see Clippy. And if I zoom in, so people might click that, hopefully not, but you never know. But you know that's basically arbitrary JavaScript that I've sent down to the browser, and you've got an awful lot of power once you can do that. So now I can send something completely different, probably a lot more convincing. And you can imagine you flick over to a tab and you see this, and you might well enter your username and password with that if you're not paying attention. You know, I've got a lot of control over that browser. So this is sort of along a similar vein. And I mentioned cryptocurrency mining earlier, and it's kind of a recurring theme at the moment. This is a really popular attack. So if I can run arbitrary JavaScript in your browser, perhaps via cross-site scripting, then great, I could do some cryptocurrency mining. And in this case, this was a slightly different attack. I'll show you a bit more detail in a minute, but this was various government websites, a lot of NHS services, even the Information Commissioner's Office was affected. There was over 4,000 websites affected by this attack. So how did it happen? Well, there's a company called TextHelp who make a product called BrowserLoud. Now BrowserLoud is an accessibility product. So that's why it affected so many government websites, because obviously they're a bit hot on accessibility. You include BrowserLoud by including some JavaScript served from the TextHelp web servers, and you include that in your app. And all that happened was the Browser Loud website, the text help website, was compromised. And as well as the normal Browser Loud JavaScript, they included a bit of additional code in there. So this is the Browser Loud script that was included. And you've got at the bottom, you've got your normal JavaScript. That was the Browser Loud code. But in the middle, you've got this basically encoded code. It's basically obfuscated, so you can't really obviously see what it is. But if you decode it, you've basically got a script which is pulling down a script from CoinHive and running it to mine Monero, cryptocurrency. So this is a really powerful attack, and I think we'll see more of this. And I can show you it in a little demo here. If I go back to Bob's Discount Diamonds, so I can log into this website. Let's clear that. Now the interesting thing is that when I type my password in here, you'll see a number of network requests. And in those network requests is my password, and it's sending it off to evilbob.io. So that's my password going off over the internet. Now the reason that's happened is this. So here's the page that this is my my template. So I'm going off to jquery.io and I'm including jQuery. Great, that's brilliant. But if I look at my jQuery, as well as the normal jQuery code, I've got a keylogger in there. So somebody's come along and modified the jQuery CDN because I've used a dodgy one. And there's a bit of an issue for me. There's a really simple mitigation for this. I mean, one of the mitigations for the Browser Loud issue would be content security policy, because in that you wouldn't have said that you would include CoinHive in your list of accepted scripts. Now, you can do something sort of similar here with a technology called SRI, which is built into certainly Chrome and Firefox. I'm not sure it's in Edge yet. But basically you have a couple of extra attributes in your script tag, the cross-origin and an integrity attribute. And you're basically saying that your external content that you're including should hash down to this hash value. Now this is a good use for SHA family. I mentioned it was no good for passwords, but it's good in this case. And so if I take this script and include it in my working script tag, like that, and then I go back here, let's reload it, or let's have the console window. So now when Chrome loads that script, it will hash it, and when it hashes it, it will find that the integrity attribute doesn't match, doesn't find a valid digest for it, so it doesn't run it, so it blocks that resource. So that resource has been compromised, but my website hasn't been compromised because of SRI. And that's a really powerful mitigation and it's really straightforward to implement. So Browser Loud have added that to their website, so you can now use that technique. One thing that does do is it pins you to a specific version. So if you're, I mean, the benefit of just including the Browser Loud script is that it would allow Browser Loud to rev the version for you. They can just make changes and it would come onto your website. But now if you have an SRI tag on there, you're effectively saying don't change this without my knowledge. So you're then having to change that version manually, or have the new attribute in there as the versions change, but it gives you a lot more control. Okay, so that's supply chain vulnerabilities. Along a similar vein, this is a recent incident where Jenkins build servers were turned into crypto mining slaves. Again, mining Monero seems to be popular. This is an example of servers sort of misconfigured and put on the internet. So I certainly, the user group I was at last week, someone said to me, yeah, our Jenkins box, we came in and it was suddenly using 100% CPU, and yeah, it was basically been owned and it was mining Monero for somebody. Now, these people would just scan for servers that they can use. Apparently this crew made about $3 million in Monero mining, so lucrative business. The final lesson for me is continuous improvement. Now, this is a fairly standard development pipeline. Plan, code, test, release, deploy, operate. Now, you might do that in really short iterations. You might be doing dev and ops like this, or hopefully you're doing DevOps like this. But where are you doing security? Quite often that comes right here at the end. But I think we all, by now, hopefully know that the earlier you catch a problem, if you've got bugs in your code, you want to catch them as early as possible. That's when they're cheapest to fix, and the same goes for security. So we want to be doing that, much earlier on, hopefully even all the way through. So for me, yeah, continuous improvement, big part of the story. So there's some resources on my blog, some links to the various AWASP projects and some other things, some of the things I talked about. On that note, thank you very much.